The next paragraph is going to be the hyperbola paragraph, and it is defined by your equation where you have 1 divided by x. So you're dividing by x, and so the variable, the input, is in the denominator. That's really important because it creates some very interesting things with your graph, as you can see. What you actually have are 2 different asymptotes, and we'll get to that later. But this line here, which is in a dotted blue, as you'll see, your graph, as it gets closer and closer to it, but it never ever touches it. So this has a vertical asymptote. It also has a horizontal asymptote, and those are both centered around that HK. So if you were to shift that HK around, what you would notice is that it does move. So as we move it to the right, you can see that the whole graph moves along with it, including those asymptotes. So those dotted blue lines are really important for us for identifying that this is what a hyperbola is. Now the hyperbola has a locator point, as all of our others do, and that's at the point HK, and we call it the center, and it's also then the intersection of your asymptotes. So as you look at wherever those asymptotes are, you're going to be able to know what the HK values are very quickly just by looking for that intersection. The graphing form is going to be y equals a over x minus h, and then plus k. So since the x is in the denominator of our parent equation, x minus h, because the h always goes with the x, is in the denominator of our graphing form. As you shift your a value, what you will see is that the whole graph shifts up and down. That's your vertical stretch and your compression. And it can also flip it to be negative, whereas you go to the 1 unit to the right of that HK, that will determine what your a value is, as you can see here. In this particular example, a is equal to -1. Now also, because you have those asymptotes, that makes some changes in our domain and range. It's kind of interesting because you can divide by any number except for 0, which is why your domain is that x cannot equal h. Because if x does equal h, you have in the denominator here h minus it, which is then 0 in the denominator, which is bad. You can't do that. So x does not equal h. That develops this vertical asymptote wherever that h value is. Your range then is kind of similar. Y cannot equal k because you have a horizontal asymptote that your graph does not touch. This graph does not have any lines of symmetry. It does have some rotational symmetry, but not any lines of symmetry. And it does have 2 asymptotes, as we said. Those are going to be at h and k. So make sure that you do include the x equals h, because h is an x value, and the y equals when we ask for those asymptotes. So take a look again at how that a value will shift and change, based upon when you move 1 unit to the right, you can always know what that a value is equal to. So when you're writing your equation into Moodle, you need to use the proper syntax. The best way to do it is to use a divided by. Now you do need parentheses around the x minus h before you finish up with the plus k. This is one students struggle with because in the graphing form here, we don't see any parentheses, but you need them when you're typing it into your horizontal line of Moodle so you can write them out. A divided by the quantity x minus h and then plus k is how you would write this into Moodle for a hyperbola.